Okay, since last time we explained about what is the squeeze theorem, and now I want to show you guys some example of squeeze theorem. First, let's rewrite the squeeze theorem. So the squeeze theorem says if g of x is less than equal than f of x is less than equal than m of x. Therefore, it's not therefore if this is a situation if and this is satisfied. And then we have another if. If that statement is satisfied already, if limit as x approaching a, that means we have a limit x is approaching a. G of a is equal to m of a. Then f of a must be the same with those two. Let's say g of a equal m of a is the volume y. It's the point y. Then f of a must equal to y2. I have a brief explanation about this in another videos, and it's pretty simple if you actually see to what this is talking about. It's like a sandwich. You treat g of x is the top part of your sandwich, and m of x is the bottom part of your sandwich, and f(x) is just the meal, just the tomatoes, just the cheese, and you're trying to squish the top part and the bottom part together to squish the cheese inside, to squeeze the hands inside to make it look like a sandwich. That's what happened. Keep this in mind. And let's do some example of this. First, before I do some example of it, I want you to know the purpose of this theorem. Why do we have to learn this? Why is this necessary? Isn't this clear enough already? Because we all know by common sense, if something is bigger than another and another is bigger than another, and you want them both equal at the same time, they must be equal. But this is the thing. Sometimes in the situation, f(x) is not defined. f(x) cannot be defined. And we want to see if f(x) is not defined, but when we approach to that x, what volume are we approaching to? We don't want to just say it's undefined, because this is math. The purpose of math is to solving all the mysteries. So we're solving one mystery, so we can use this mystery as a law, as a ruler, to solve another mysteries. Let's see. Why are we need this? The purpose of this is when you only have f(x), and when you're only being asked what happened is the limit x approach a, what is of f(x), and if you just plug in a for f(x), and what happens if the function is undefined, but you still want to see what it really is beside the point of undefined. Because undefined, the meaning of undefined is just you cannot define it. Doesn't mean it not exists. What happened is actually exists. Which volume or what variable will there be? This is the purpose to using squeeze theorem. You will see what I was talking about if we go into the examples. First, there are two types of examples. Two types of these examples you will most likely given on the test or on the textbook. First type of example is that equations, the functions g of x f of x and m of x. It's all given. It's all given. In this case, what does it mean is it's all given? That means you know all three of the functions, and they ask you for the limit of the fx. For instance, let's do an example on this. I will just use, so let me see if this good to use the y one. Okay, let's do a graph. Let's do a graph on this. So that is the x-axis and this is the y-axis. Let's say we have two equations. The fx and mx is given at this second. So the gx is and nx is given at this second. Sorry. So gx is its absolute value of x. Absolute value of x. So what does the absolute value of x might looks like? Maybe you know it already. It's just y equal x, but going to the same way on both direction. So let's draw that. So it might look very close to this. Right. This is absolute value of x. It makes sense because no matter what x is, it's always equal than y. The absolute value of x is always equal than I. So x is 1, y is 1. X is -1, y is -1. I mean, y is still 1 because it's absolute volume. And let's plug in a second equation. This time we're using a different color. M of x. M of x is negative. It's negative volume of absolute volume of x. What does that mean is it's just negative of this top function over there. And if you graph that on the graph, you will have something like this. And I hope you guys really can graph these simple functions right now, because calculus is really require a lot of visualizing. And if you can visualizing all of this stuff over there, then you are very close to success. Okay. This is the mx minus x. So there we have the question. Oh, actually, before that question, let's do another graph. We just call f of x. This is just a function. It's not equal anything. It's not defined. It's not defined yet. It's just a random function. We don't care what this is. Let's say f of x is less than g of x, because g of x is always on top of it. It's greater than m of x, and n of x is always on bottom of it. So we don't really care what that looks like as long as this function and never break the rule of it. So it might look like this. It can look like the other way too, as long as not outside of it. It's not over the red one and not under the green one. Okay. And we say this. Now let's set out the equations. The limit is x approaching 0. G of x it's less than, greater than f of x. I mean, it's less than, equal than. Oops, this is wrong. This is wrong. So let's redo it. What we want to do is n of x is less than equal than f of x, and f of x is less than equal than g of x. Yeah. And as the limit x approaching 0. So what is this? And they asking for what is the limit? What is the limit when x approaching 0? F of x. This is the very simplest form question. All the information is given, and you might see this on the textbook. You might not, depend on the difficulty of the textbook. So let's plug in g of x and m of x that at x approaching 0, and we got g of 0 is actually just 0, because 0 x to absolute power is just 0, and that's also equal to n of x. It's also equal to n of 0, because negative 0 is just 0. So what is fx of f of x when limit x approaching 0? And go back to the theorem we have over there. If this is all true, so g of a we say is 0, so g of 0 equal n of 0 and equal to y, and which is 0. That means f of a, f of 0 must be 0. Therefore, we know that f of 0 must be 0. In another word, the limit is x approaching 0, fx equal to 0. And I really hope you can see that on this graph over here. This point is just 0, and they meet each other. They are the same. And we don't know if this purple squishy line, the purple function of fx, does exist or does not exist at the point 0. But we can say that as the limit of x approaching 0, fx is approaching 0. I hope you can get a view on this over this, because it's really helpful, and if you can understand this example, you can definitely go any further. Okay, let's have another example. Let me erase all of this. Let me see how I erase this. How I'm going to erase this. Okay, so we still have the three function is going like that. Eraser. Oops, how I do this? Okay, let me figure out how to erase this first. So I want to erase all of this and do another and do another. I want to do another example of this, and how am I doing? I don't like this color. Let me see if I can replace the color to black. I like it black. Oh, there you go. And we want to delete this too. Okay. So still have three functions, but this time functions are different. Functions are different. We have a function of the same. It's the same. It's the same type we're doing. We have g of x and n of x is given. So function g of x is equal to x squared plus 2, and m of x is equal to negative x squared. Negative x squared plus 2. And I really hope you can see, I mean, you can, I really hope you know the graph, the sample conv graph in your mind already. It's gonna be your second nature or third nature. So whenever you see x squared, you know, oh, that's a smiling face, it's curved up. And when you see plus 2, you know it's going off at 2 spots. But this time I'm gonna show you what the graph looks like. And we want to find a curve. Let me see if this is a curve enough. I can do a curve of this. No. I don't want this. Let me do a curve of it. Interesting. No. Okay, I see how this is going on. Okay. So I think how to do curve in this ping program. Just yeah, okay. Here is g of x plus x squared plus 2. And we have another function. Oh, oops. We have another function. We have another function of negative x squared plus 2. So it's gonna look like this. Oh, relatively close to this. And again, we have f of x. And just any function. It can be any function as long as it's a function. So you have f of x, it's in any function that's under the g of x, but it's on top of m of x. That means g of x is always greater than or equal than f of x, and n of x is always less than or equal than f of x. Fair enough? Okay. And sometimes this problem, the limit, if all the functions are given, the limit is just really where these two functions, the two knowing functions, met each other at a certain point. But I think, I'm not 100% sure, but I think the limit is always given with the question too. So let's say it's asked, what is the limit when x it's approaching 0? When x is approaching 0 of the function f of x. And we can really see this already. So what is x squared plus 2 when x is 0? So let's do this over again. So g of 0 is just really 2. Because if you're plugging 0 for x squared, you're just gonna get 0, and plus 2 is just plus 2. And it's also, you might see it, it's also equal n of 0. Because if you're plugging 0 into x squared, it's 0 squared, which is 0 to any power is 0, but 0 cannot to a 0 power, that's undefined. You can search online, it's a fun fact too. But negative 0, in this case, 0 to the second power is just 0. So negative 0 is just negative 0. Plus 2 is just 2. So they are the same thing. And at this point you might see already, because according to this theorem right here, according to if g of a equal n of a, that's equal to certain point y, f of a must be equal to certain point y. According to the squishy theorem, according to the sandwich, I would say. So at this point, f of x, it's really equal to 2, because these three functions are equal to each other. And I don't want to say f of x, because it might just confuse you. Let me see. Huh. Now I don't like the eraser. But you understand what I'm saying. It's f to the 0. F to the 0 is really just 2. Because these three functions, if this top function and bottom function are each equal to each other at a certain point, f of x, the middle function, must be the same thing. And if we look at the graph, this is 2. Yeah, we know it's just it is. So we solve the question now. As limit x approaching 0, our f(x) is really just 2. Just equal than 2. And I hope you really understand this. It's very simple. The first type of example are very simple intuition. And when we get to the second type of example, which g of x and n of x is not given, the fx instead the f of x function is given, and they hope you found the other two functions out and found out what the limit is. We will talking about this in next videos, but I hope you really understand this intuition right now. If you don't understand this process, please leave a comment on Facebook, on the YouTube channel, so I can explain what I did and the reason I did it. Okay, I will see you in next video.